Hello again, friends. Welcome back to my home, and now we are going to be continuing to go over the final from pages 4 through 6. We're going to start off with an instantaneous rate of change problem. So what is the instantaneous rate of change at x equals 2 for the function given by f of x equals x squared minus 2 over x minus 1? So just to remind, instantaneous rate of change, that phrase means we're looking for the derivative. So we're looking for f prime when x equals 2. This is set up to be a very clear quotient rule problem. And so I see no reason not to do it like the quotient rule. So again, quotient rule is v du minus u dv over v squared. So with v as x minus 1, u as x squared minus 2, we are going to have x minus 1 times the derivative of x squared minus 2, which is just going to be 2x, minus x squared minus 2 times the derivative of x minus 1, which is just 1, all divided by x minus 1 squared. I like to do a little bit of cleanup at this stage. It's not necessary. It's a little bit nicer for me to clean up a little bit before I plug in the x equals 2. So I'm just going to clean up to the 2x squared minus 2x minus x squared plus 2 over x minus 1 squared. All right. Now when x equals 2, this turns into, and then 2x squared minus x squared. We'll just do that. That's going to be equal to 2 squared minus 2 times 2 plus 2 over 2 minus 1 squared. 2 squared is 4. 2 times 2 is 4. These will cancel out. So we'll just get 2 over 2 minus 1 is 1. So it's just going to be equal to 2. That is our instantaneous rate of change. This one requires a little bit of thought. So if f is a linear function and both a and b are positive and a is less than b, then what is the integral from a to b of f double prime of x dx? I saw a lot of people say correctly that this is equal to f prime of b minus f prime of a. And that is correct, right? But you can be a little bit more specific than this. This uses the fundamental theorem of calculus to figure that out, by the way. You can be a little bit more specific than this. I told you that f is a linear function. So, f of x, we can just say that's mx plus b, right? Well, if f is a linear function, then f prime is just going to be equal to m. So this equals to m minus m, because it doesn't matter whether you're at b or a, f prime is always the same, which is equal to 0, which is the more specific answer I was looking for. You can also get at this another way. If f prime of x is equal to m, then f double prime, well, that's just equal to 0. And so if you're trying to integrate from a to b of 0 dx, doesn't matter what a and b are, that's going to be 0, because you can think about that any number of ways, but it's going to, adding up an infinite number of zeros, doesn't matter, you're still going to get to 0. So those away for both of them. But yeah, this is one of the rare ones where you have to think about it just a little bit and bring in some knowledge of what the terms actually mean to get this one. All right. We have here a piecewise defined function. F of x is natural log of x for x between 0 and 2, inclusive of 2 on this side. And it's equal to x squared natural log of 2 for x between 2 and 4. And ask what is the limit as x goes to 2 of f of x. Now, they didn't specify. and specify a side. So let's look at both sides. What is the limit as x goes to 2, but not just to 2 from the lower side of f of x? Well, if we're using the lower side, we use this definition. So that's going to be the natural log of 2. Great. And we look at the limit as x goes to 2, but from the higher side. If we go from the higher side, we use this definition. So that's going to be 2 squared natural log of 2, which is 4 natural log of 2, which does not equal this. And since the limit from the negative is not equal to the limit of the positive, that means the general limit does not exist. Does not exist. If you're pressed for time, just writing DNE is enough. Everyone will know what that means. Graph function f is shown in the picture above, has a vertical tangent at point 2, 0, so that's this point, and horizontal tangents at the points 1, -1, and 3, 1. I kind of actually messed up. This is 3, should be 3, 2 for my drawing. I think that's just a drawing. Prospect, doesn't actually matter. For what values of x, where x is between -2 and 4, is f not differentiable? So remember, for not differentiable, there's 2 ways of doing that. It could be not continuous. There are 3 ways. 3 ways. Continuous. Are there any points where it's not continuous? Well, yeah. Right over there. That is not continuous. So we have a value of x equals 0, for which f is not differentiable. We could also have a cusp or a corner. We don't really have those here. But we could also, and this is kind of like the lesser known one, vertical tangents. Means that in a vertical line, the slope is considered to be infinity. And infinity is not a number. So when you have a vertical tangent, the derivative at that point we consider to be infinity. So it's not really defined in any sort of way. And we do have a point of vertical tangency. That's at this point I circled earlier, 2, 0. So that's when we have x equals 2. So when we're looking for what values of x between -2 and 4, is it not differentiable? We'd say x equals 0 and at 2. All right, we have a particle. It's moving along the x-axis, so that its position is given by x of t is t squared minus 6t plus 5. For what value of x is the velocity of the particle? 0. This is one of the ones where you don't necessarily need a calculus if you know a little bit about the function. We see that this is a quadratic function. All quadratic functions have the shape either that or that. So we can tell that the point where its velocity is equal to 0 is going to be at the vertex. And so we're looking for values of t. That's the t coordinate of the vertex. Vertex is at t equals -b over 2a, where this is b, this is a. So that's going to be -6 over 2 times 1. 6 over 2 is 3. So you don't really need calculus for this if you know a little bit about quadratic functions. Let's say we don't, or we forget. We can always forget stuff. So if we're looking for velocity equal to 0, well, that's the first derivative of the position function. So our velocity function, we're going to take the derivative of the position function. Derivative of t squared is 2t. The derivative of -6t is just -6, and the derivative of 5 is 0. So you have this. We want the velocity equal to 0. set that equal to 0, 2t equals 6, and t equals 3. You get the same thing either way again. And it might be argued that this is honestly slightly faster if you are good at taking derivatives. I'm just, pointing out that there's a couple different ways of doing it, and you should do whatever makes you feel most comfortable. All right, straightforward, take the derivative problem. If y equals the secant of 3x squared dy dx, this is a standard chain rule. Set up with trig functions here. So the derivative of secant is secant tangent. So dy dx, we're going to do secant tangent. And inside of those, we leave the inside of this unchanged. So it's going to be 3x squared. Then, by the chain rule, we have to multiply by the derivative of the inside. So the derivative of 3x squared is 6x. So this is just fine. You can just leave it like this. Not asking for anything more. Traditionally, if this was multiple choice, you would not see the 6x back here. They would have taken this and replaced it up here. So it would be written, if this were in a multiple choice section, as 6x secant 3x squared tangent 3x squared. Exactly mathematically the same. So if this is free response, or if you were using this to calculate something else, just leave it like this. You don't need the extra step. But recognize that this 6x, since it's multiplication, can be kind of anywhere in here. If f of x equals tan inverse of 3x, f prime of x, so we got another chain rule problem. This one, trying to get you to remember the inverse trig functions. Derivative of tangent inverse, just to remind everyone, is 1 over 1 plus x squared. So we do that, replacing x squared with 3x, we get 1 over plus 3x squared multiplied by the derivative of 3x, which is just 3. So you would get 3 over 1 plus 9x squared. What is the equation of a line tangent to the graph of y equals x plus cosine of x at the point 0, 1? Okay, so if you want the equation of a line, you need a point, which I have helpfully provided. It's 0, 1. And you need a slope, which we get through the derivative. Dy dx is equal to 1 plus derivative cosine is negative sine of x. And so we plug in x is 0, sine of 0 is 0, so this becomes 1 minus 0, which is 1. Hey, slope is 1. Amazing. So point is 0, 1, slope is 1. We'll start with point slope. We have y equals 1 plus 1 times x minus 0, which just becomes y equals x plus 1. Amazing. All right, this one's got a lot of words. We're gonna have to think about this one a little bit. The graph of a twice differentiable. So it has, we have f, and f prime of x and f double prime of x exist. That's what twice differentiable means. We want to arrange f of 1, f prime of 1, and f double prime of 1 in increasing order. So I've called out this is 1. So from this graph, we would interpret that f of 1 is equal to 0, because it's just crossing at that spot. Okay, so we've got f of 1 as 0. Let's look at f prime. Now, f prime is the slant of the graph. If it's increasing or if it's decreasing, it's slanting up, slanting down. And we can see that this graph, if we kind of draw in a derivative line, which we don't really need to, we can just kind of look. This is an increasing graph at this point. We don't know by how much, but we know enough to say that f prime at 1 is greater than 0 because it's increasing. So already, if we need to put things in increasing order, we know that f of 1, which is 0, has to be less than f prime of 1. Now let's look at f double prime. F double prime, second derivatives ask about curvature, whether it's curving up like this or curving down like this. So if it were curving up, that would be a positive second derivative. But this one, as you can see, curves down. We call this concave down. Because the cave part of it is facing down. Concave down, our second derivative is negative. That means it's less than 0. Okay, so we've cut up all the information, and now we look at this and it's like, oh, we have enough to actually arrange this. If we want to put this in a list in increasing order, well, the negative number is the least, so we're going to start with f double prime of 1 has to be less than 0, which is f of 1, which has to be less than a positive number, which is f prime of 1. You don't necessarily, for this, you don't need the less than signs. If you just wrote it as f double prime of 1, comma, f of 1, f prime of 1, that'll work too. Either way, that is a list in increasing order. Just had to think about it just a little bit. And that's it. Thanks for stopping by. We'll have the other, there should be 2 more videos for this final, and they should be up shortly.